AI-generated 3D models have got so much better. A few weeks ago I published a video looking at some of the best 3D model generating AIs available to use for free and tested them to see how they worked in the world of 3D printing. The AI industry is moving so fast, and since then there has already been a huge amount of innovation and some new players on the block. So today I'm going to be testing some of the new and improved AI mesh generators to see how they work with 3D printing, so let's have a look. In my previous video on AI mesh generation, I covered a whole range of processes, from having LLMs write code that would create models, to having 3D models generated from a video. This time, however, I'll be focusing specifically on text to 3D and image to 3D. I'll be looking at how some of the tools that I used in that previous video have improved over time and how they stack up against new players on the block. One of the greatest things about 3D printing is the ability to create whatever you can imagine. For me, and for many people in the world of 3D printing, one of my favourite elements of this is the design process. I love the challenge of designing something that I can otherwise only see in my head, and then learning the skills necessary to make that a reality. But much in the same way that a chef doesn't necessarily make every meal that they eat, and a photographer may use the camera on their phone in auto mode during personal situations, we don't always have the time or the energy to design everything we need from scratch. With text to 3D and image to 3D, it's still you that is providing the seed of the idea that it then creates, and it's still your judgment that then decides whether its creation is up to scratch or if you want to run the prompts again. There is of course the argument that because these AI models were trained on other people's work, nothing that they create is original, it's all just copied. But the same could be said for anything that's been designed by a human. Everything we do, everything we create, is inspired by what we see and experience in our lives. You don't get a famous movie director who has never watched a film or TV show created by anyone else up to that point in their life. In the early 1900s, American writer Mark Twain famously said, "There is no such thing as a new idea. It is impossible. We simply take a lot of old ideas and put them into a sort of mental kaleidoscope." And I feel that this pretty well encapsulates what generative AI generally does. Whether you use 3D generative AI to create your final model for print, or you just use it to inspire you with different interpretations of your original idea, which you can then go and design yourself, it can be a useful tool regardless of whether you're skilled in CAD. As I mentioned earlier, in this video I'm going to cover a range of different platforms in two different categories. I'll be looking at Rodin Gen 1 by Demos Tech, charmed.ai, and 3D AI Studio. I'll also be looking at meshy.ai for text to 3D and Instant Mesh for image to 3D, which I looked at in my previous video. Let's get started with text to 3D, which is where the AI will generate a 3D model based on a text prompt which you enter. In my previous video I used this method to prompt for simple rocket ships and also a phone stand in the shape of a human hand, and this is one that was generated by meshy.ai. Whilst you can use these tools to generate all kinds of models for a whole range of use cases, they are currently primarily produced with things like animation and games in mind, and therefore aren't so well tuned for designing practical real-world objects. Okay, so to start, let's play to these tools' strengths and create a character-based model, seeing what quality they can actually produce and how suitable it is for 3D printing, and we'll start out with Rodin Gen 1. You can access Rodin Gen 1 at hyperhuman.demos.com. When you load it up, you'll be presented with a nice and simple user interface. At the bottom here, it displays generations by other users that have been made public, and right in the middle here is where the fun happens. This box represents an input that you'll be submitting for a generation. You can click the plus symbol to upload a photo, and we'll look at that later on, or you can click below that selecting text input. Here you can enter your text input for the model that you'd like to generate. As we're starting out with a character-based test, let's prompt for an evil orc king with big eyes and mouth. And we'll throw in something a little out of character here, and we'll have wearing a Stetson and sat on a throne. Once you're happy with your prompt, hit the purple tick button. Now, differently to how many other AI generators work, which would now produce 1 to 4 draft 3D models, Rodin 1 uses the text prompts to generate a 2D image. Once you've got a 2D image you're happy with, it will then generate a 3D model from that, with further tweaks based on your text prompt. This can be great for a few reasons, but simply from a user experience perspective, it makes the whole process so much faster. This image only took a few seconds to generate, but other platforms can take minutes to generate their 3D drafts for you to choose from. And here's the 2D image that it's generated, clearly showing an orc sat on a throne. His hat is more like a top hat than a Stetson, but other than that, this looks great. If we click this pencil button in the top left corner of the image, it allows us to edit our text prompt. So let's change this to an evil robot king with big camera eyes and mouth, wearing a Stetson and sat on a throne. Then click the purple button again to confirm the change. This will then run your edited prompt and create a new image, and here he is. This is our robot sat on a throne. The tick button on the right means that you're happy with this image, and if you click this, it will approve the image for use as an asset when it's generating the model. The X button on the left means that you don't like this generation and you want to cancel this prompt completely. And then this purple button in the middle will simply rerun your existing prompt and generate a new image. He still looks like he's wearing a top hat rather than a Stetson, so I'm going to run this again. I'm happy with this, so I'll click the tick to accept it. With the image accepted, it's now created a new plus box next to it. We can use this to add an additional image or text prompt, and we can have up to 5 in total for a single generation. The features and stylings of each asset would then be combined into a single object when generating the 3D model. I'll be covering this a bit more later on, so for now let's just hit generate. This will then generate a draft of our 3D model, and once it's complete it will open a new window with a lot more options. To the left here we have our draft 3D model, which you can then rotate to look around. This is neither the final design nor the final quality, so don't worry if it's not quite what you were expecting. Up in the top right, under Geometry Generation, it creates its own prompt based on its own interpretation of the 2D image that the 3D model was created from. If there are inaccuracies in the description which are reflected in the model, or if you'd like to make some additional changes or tweaks, you can make them here. This recognises the hat as a top hat, so let's change that to a Stetson here. Below that you have a set of quick selection boxes to choose different preferences for your model, whether you'd like it to be simple or complex, or if you'd prefer smooth or sharp edges, etc. It will pre-select the ones that it thinks are most suitable for the generation, but you can just select and deselect whichever you'd like. Next to that are the advanced settings, though these are only accessible if you've got a paid subscription. I won't be using these advanced settings in this video, but I'll definitely be experimenting with them more in future videos. None of these settings in the geometry generation section will have any immediate impact, but any changes that you do make here will be taken into consideration when you click redo. Clicking redo will generate a new draft model based on the initial prompt and image that you selected, and will take into account any adjustments that you've made here. Because I'm signed in with a premium account, I can use this redo function 50 times per initial prompt, but on a free account you can still use this, you're just limited to 10 redos per prompt. Let's click redo now to see how it changes our model. The overall design has stayed the same, but I do like the small tweaks it's made, including the improvement to the hat, so that's good. Once you're happy with your draft, you want to hit confirm. Before clicking it, if you've got a premium account, you can select how many polygons it generates the model in, which is effectively the resolution or the final quality of your model. But even on a free account, this is locked to 10,000 polygons, which is still higher than many other platforms. Even some paid ones are capped at just 15,000 polygons or less, so the free account restriction here isn't too limiting. Once you've selected your preferred resolution, click confirm. This tends to be pretty quick, and I've generally found it takes between 10 and 35 seconds even on a free account. This will generate your final model. Now I believe that the model it displays here is at a limited resolution, so even if you've selected 30,000 polygons, this would still be showing you a reduced quality preview. Now you've got your final geometry, you're able to generate a material for it. You can adjust the prompt for the material it generates, and you can upload additional images of objects or textures to tune the desired style. As we'll be 3D printing our model, this isn't so relevant to us, but whilst we're here, let's click generate and see how it looks. Just as when you generate your initial mesh, you're able to redo your material generation with altered settings if you want to. When you're happy with your material, just click confirm, but again, as we're 3D printing this, we won't be using the material generation anyway. That said, you could perhaps use the material generated as a guided suggestion when manually painting it either in your slicer or in post. Under Pack, we can select the geometry quality and the file type. Generally with 3D printing, you'll want either base model or, if you've got a paid account, high poly. LOD, or level of detail, limits the export format to .fbx, which is more commonly used in software such as Maya and 3D Max, and won't be something we need to worry about here. LODs are commonly used in gaming and animation, having multiple copies of the same model in varying levels of detail. Let's select High Poly and STL, and again, as we aren't using the material, we can just move past these settings, and for now we'll hit download. Alright, let's get this scaled up and take a look. It seems to have come out really nicely. The first thing that really strikes me is how smooth and defined the surfaces and edges are compared to models that I've generated with AI platforms in the past. Not just because of its increased poly count, but the beautiful lack of that AI bumpy wavy surface texture that we're used to seeing with these AI models. It's nice to see here that the chair legs have all been designed with flat bases that are all on the same level, which means that it can be printed on a print bed without having to be adjusted. The feet are raised off the ground, but that's kind of acceptable and it coincides with the design of the robot. I love the detailing of the wood panelling on the sides here, especially as it recognises that that is needed on both sides of each arm. That's a really nice touch. He definitely has a bit of a Futurama Bender look about him, but this definitely captures the prompt which I gave for a robot king with camera eyes, wearing a Stetson and sat on a throne. Well, I'm really impressed with the level of detail and the quality of the geometry, so I'm going to give him a quick paint job just so we can get a better idea of how it would look all together. That looks pretty good. There's obviously going to be a fair amount of support material that's needed for this, especially underneath the throne, but if using organic tree supports, it actually shouldn't be that much. We'll get this printing in a single colour to better show the quality of the geometry, and now we'll see how the next AI tool does at this task. Next up we have meshy.ai, conveniently available at meshy.ai. This is the tool that I used in my previous AI mesh generation video to produce this phone stand shaped like a human hand. I already covered the meshy user interface a bit in my last video, so I won't go into it too much here. As well as the prompt and negative prompts, you can also select the style that you'd like your model to be generated in, such as realistic or cartoon, though I have a feeling that this mostly affects the material generation rather than the 3D mesh itself. Unless you have something very specific in mind, I find it best to usually leave this in auto mode so it has flexibility to pick whatever it thinks would work best with your prompt. Let's enter the same prompt that we ended up using in Rodin Gen 1, an evil robot king with big camera eyes and mouth, wearing a Stetson and sat on a throne. And click generate. I mentioned earlier about how the 2D image initial design process that Rodin uses makes it significantly faster, and this is a good case in point. Whilst you only get one 2D image at a time, on that they're pretty much instant, but this took just shy of 4 minutes to generate these suggestions. So let's have a look at how these suggestions have come out. I can instantly see that it looks like the second one is probably going to be the best, so we'll circle back to that. This one looks like an armless, footless man either being absorbed into the chair or doing a fairly good Han Solo Carbonite impression. This one, I'm not entirely sure what's going on here. It's like half a keg wearing a dunce's hat has been placed on a chair, and the chair itself is holding onto a lump of, I don't know, coal? This fourth one actually looks pretty similar to the previous one. And finally we have this one. There's definitely a little more definition here with the character than in the others, but not only does our king appear to be missing arms and lower legs, but it's also completely ignored the part of my prompt requesting a Stetson. Now I know this is a draft, and because we're 3D printing we won't be using the material anyway, but I'm not sure what the goal was with this rainbow tie-dye colouring. Let's hit refine on this one and see how it goes. Well, refinement did only take 30 seconds, but it didn't seem to do a huge amount of refinement on the mesh or the material. Let's get this downloaded in the STL so we can have a closer look in our slicer. Well, I wasn't hugely impressed when it had its texture on, but as a single colour you can see that this really doesn't have much detail or definition, and it's clearly still suffering from this horrible lumpy AI deformation. This carries on to the base of the throne, meaning that it wouldn't be flat to the print bed. As a result, we'll need to perform a simple cut to give this a flatter base for printing on. I honestly don't think that it's even worth spending the time to paint this one, so we'll come back to the print on this in a bit. Next up, 3D AI Studio. Now in full disclosure, whilst I do have a paid account with Demos Tech's Rodin Gen 1, all of the tools that I'm covering in this video, including Rodin Gen 1, are currently available to use to an extent for free, with the exception of 3D AI Studio. Now I already wanted to feature 3D AI Studio in this video after having used it when prepping for my previous AI video and it didn't quite make the cut. However, whilst it was available to use for free at the time, unless I'm missing something, it seems to now be exclusively available to paying users. But I had been impressed with what I saw of it when I was using it for free, so I thought now it might be interesting to see if using an exclusively premium service made a huge difference to the output. As a result, I got their basic package for this video, which was $14 a month, giving you 1,000 credits, and that works out around 40 text to 3D generations. You can access this at 3daistudio.com, so let's enter the same prompt here. Now 3D AI Studio does generate 3D models from the initial prompt rather than 2D images, but only one at a time, so you're not waiting for 4 3D models to be generated only to decide that you don't like any of them. After around 30 seconds, it's given us this draft model, which is fairly well painted with its material and certainly has far more detail in its mesh than we got from meshy.ai. It is, however, difficult to see exactly how much detail there is in the 3D mesh with this material texture applied, so we'll need to check that more when we're in the slicer in a bit. The throne is certainly a grand one and seems to feature some really nice details. Now, even though this is the first stage of generation, you can actually download this model and use it as your final design if you want to, but there's also the option to refine it, and as we've done that in the other tools when the option's been available, we'll do the same here, so let's hit refine and get our final model. Now it's worth noting here that not only will this refinement process take up to 10 minutes, but it also will cost 30 credits, which will affect how many models you can generate with your monthly allowance. But as we are here to see what these tools can deliver, let's go ahead and see what this gives us. And this is our refined model. Now, as standard, 3D AI Studio only generates these models available to download as GLB files, which won't be compatible with most 3D printing slicers. So what you want to do is click the Stack button and generate LODs. This will allow you to set between 2 and 6 LODs and define the quality for each one, but we don't need multiple models, so just make sure that one of them has 15,000 set, which is the maximum face count that you can select here. Then set export format as OBJ or STL and finally hit generate LODs. Once it's generated these LODs, you can then select the 15,000 version and download that. Well, this certainly has a lot more definition to it than the meshy one did, but there's also some disappointing factors. There's something weird going on with these hook hands, though granted he is a robot, so that could just be what his hands look like, and he seems to have some sort of questionable robotic codpiece here. It has included a Stetson as requested in my prompt, but it, along with the whole robot, appears to be doing a Han Solo impression melting into the throne. Which leads me to my other issue. Now, I actually really like the design of the throne here, possibly my favourite so far, but if I slice this and look at the bottom layer, you'll see that just like with the meshy one, it doesn't have a flat base, so we'll need to cut the bottom off of this model too. I think as we're looking at the quality of the mesh generations here, I won't paint any of these for printing, and we'll just print each of these in one colour, so let's move on to our final tool for this category. Finally, we have another newcomer to my AI 3D Gen lineup, and that is Charmed, available at charmed.ai. As I mentioned earlier, all of the tools that I'm covering in this video, excluding 3D AI Studio, have free versions available, and that's what I'll be using here. Now, the only option that we have other than entering our prompt here is whether or not we want a riggable character. This is for if you're generating a character for use in games or animation, and effectively tries to make sure that it generates it in a T-pose rather than a natural pose such as with their arms crossed, to make sure that it's easier to rig them with a skeleton. As with 3D printing this, we won't need that, so we'll leave it turned off, and this should also give it more flexibility for a better design, as it won't be restricting how it can create something. We'll enter the same prompt again, and then in the bottom right you can select how many previews to choose from that you want to generate, and then hit preview. Similar to with Rodin Gen 1, charmed.ai uses the text prompt to generate 2D images, and it took just over a minute to generate these 4 previews. There's certainly some creative out-of-the-box thinking with these. This first one looks great, though it has replaced the Stetson with a crown, and I'm not entirely sure what these things on the sides are. This second one is a fun interpretation of the camera eyes part of the prompt, but some of the shapes and relative sizes are a bit odd. Still, I like the creativity here. The third one appears to be wearing more of a top hat than a Stetson, and is sat either cross-legged or entirely without legs on a desk chair rather than a throne. This final one seems to be the most similar in overall style to the ones that we've generated with the other tools, but this coincidentally seems to be featuring an orc or goblin rather than a robot, despite the fact that I only ever mentioned orc in the initial prompt I made in Rodin Gen 1 and never ran that prompt here. Let's select option 1 as it's generally the most accurate to the prompt and 3D print suitable, then we'll see how it's come out. Well, that took just under 12 minutes to create, which I believe is the longest of all 4 of these tools by quite a bit. Let's take a look. And here it is. I actually quite like the design concept behind this one, more of a retro-futuristic concept of a robot wearing medieval armour, but from what I can tell, a huge amount of this detail is only from the colour material, not the mesh, and this crown, that shouldn't even be there based on my prompt, is a bit of a mess. So let's get this downloaded and take a look in the slicer. Well, this one features significantly less detail than its textured preview led me to believe. Out of all of today's tools, it also suffered the worst from this wavy, bumpy surface, with the crown, as I said, being a meshy mess, and the base also needs to be trimmed so that it flats the print bed. Well, that was interesting to see how each of these tools fared with a task that should be playing to their strong suits, but how did they come out when they were 3D printed? Both Charmed and Meshy produced models which, outside of a test scenario, I wouldn't feel would be worth printing, but perhaps the textured previews could help inspire concepts that you design yourself. 3D.ai Studio was significantly better, and I wondered until now if it was going to shine out as producing the highest quality model here. However, when put side by side next to the one generated by Rodin Gen 1, there's a clear difference in performance and quality. The difference in results between these currently available tools is quite remarkable, especially when you consider that all of these were generated from the exact same prompt. But whilst impressive, this is obviously only one test of one feature of these tools. Now, I'm guessing it's not that common that you're going to want a model of a robot king wearing a Stetson and sat on a throne, though this sort of result would be great if you wanted unique models of your characters and monsters for your D&D game. Now, this was playing to these tools' strengths as they are designed for creating characters for animations and games. Let's try making something a bit different that we can then turn into a practical object. Now, with basic CAD, it can be fairly easy to just throw together some simple shapes and create a fairly functional object. But what I can struggle with is designing a decent, organic-looking model. I want a pot to store things with on my desk, and I want it to look like an organic tree stump. Let's forget about the pot side of things for now. I'm going to use each of these tools to create a 3D model of a tree stump, and then I can quickly edit that into a pot directly in the slicer. I'll prompt for a highly detailed textured tree stump with flat base, and that will hopefully even influence it to include some bark texture in the mesh. Meshy gave me these 4 previews. I'm not entirely sure what was going on with these two, especially down at the base, but this one here looks more like what I was after, so let's refine that. That looks fairly good, a lot better than the meshy robot king at least. 3D.ai Studio produced this. It looks great, though I am aware that a lot of this detail is from the applied image material. Let's get it refined. This looks good. I really like the inclusion of this knot on the side of the trunk. Charmed.ai produced a similar thing to Meshy with this weird flared out base, and I have no idea what's going on with the bottom of this one. But this one at the end looks the best of these 4, so let's grab that. This looks a little simpler than I was hoping for, but still okay. And finally, Rodin Gen 1 gives us this. I really was hoping to get these nice splayed out roots, and 3 of these AI tools have delivered on that without me needing to prompt for it. It's also kept some nice detail in the trunk here too. Now, with Rodin Gen 1, once you've generated your mesh, you can click Mesh Editor in the top right corner here, and this will then take you to a basic mesh editor that will allow you to make basic tweaks and repairs to the model before you download it. I'll just draw a random shape on top here to see how it comes through when we export it. Now let's get them imported into our slicer. Well, as with my previous experiences with it, Meshy still suffers from this bumpy AI surface texture, and the model itself seems fairly simplistic, but I do like the roots. Unfortunately, it hasn't applied the flat base that I'd prompted for, so we'll need to cut these at the lowest suitable point to minimise cutting away too much root detail, but allow for a flat base to print on. Now, if I use a negative volume, I can cut out the area that I want to use for my pot, making sure it's off the base a bit so I don't cut a hole in the bottom. Then we slice it, and we can see that it's cut out our pot shape. 3D.ai Studio has produced a really nice looking mesh here, though it looks less suitable for my use case or 3D printing in general without considerable support and needing some other modifications. Not only is the base not flat as per my prompt, but there's also a big hole running into the core from the base. So with this, let's start out by cutting it to give us a flat base to print on. Unfortunately, because of how these are shaped, we're losing quite a bit of detail in these roots. Now let's add a part to the model to fill in the hole at the base, and we can just resize this and position it to fill in that hole. Finally, we'll add our negative part to cut out the shape for the pot at the top, and here we go. Now immediately what I realised when importing the tree stump from charmed.ai is that the preview on the website had loaded upside down, and I'd apparently not looked underneath it, so I hadn't noticed that it actually had generated it as a pot shape for me already, despite not actually being part of my prompt, so I'm not sure whether it should be gaining or losing points for that. You can see here that even though this doesn't feature any roots, the base of this still isn't flat, so again we're going to need to cut it. It looks like we can rotate it a bit slightly first, so we're cutting away less of the model. This also featured the dreaded AI bumps along the surface, but when you look inside it gets weirder. It almost looks like a 3D visualization of an audio waveform. I could clean up the internal base of this with negative volumes, but it would take quite a bit of work from me, as due to the shape of this trunk, it would involve applying quite a few negative prompts to remove it without cutting away any of the walls. And whilst I have made a couple of quick tweaks on each of these tree stumps, like cutting the base and adding the cup hole, the whole point of using an AI generator is to reduce the workload, so I'm not sure that it's worth doing for this. Let's move on. Finally, we've got the tree stump from Rodin Gen 1. Now, as with all of the others, this also needs cutting to provide a flat base for printing. In hindsight, I could have probably prevented this issue with all of these AI tools by adjusting the prompt. You can see the shape that I edited on the top with the built-in mesh editor, but other than that, whilst it definitely is a fairly simple model, it has some nice subtle texture running across the surface whilst avoiding any of those AI bumps. I'll be keen to see if that translates when printed. Now let's get that cut applied and we can get these printed. Well, I think all 4 of those tools did okay on this one. If you just needed something like this super quick and you weren't too fussed about the specifics, any of these would have probably been alright. A big part of this likely comes down to personal preference, but I'm personally not a fan of the one from Charmed, which doesn't look especially tree-like and has that pretty bad mess inside. The meshy one is okay, but I feel almost like it looks more like a starfish than a tree, and there's fairly little detail on the trunk. As with the Robot Kings, the 3D AI Studio and Rodin Gen 1 trees are definitely the best of the 4. Of these 2, I'd say I personally like the look of the one from 3D AI Studio a little more, mainly due to the inclusion of this knot on the side of the tree. However, that also required a lot more repair work from me, not only cutting off significantly more detail from the bottom of the base, but also filling in and repairing the hole in the bottom. So I think it ties with the Rodin Gen 1 tree, which produced a much more 3D printer friendly model and still features a nice tree aesthetic. So that was an overview of how these tools do with text to 3D, but the other feature we're going to be looking at here is image to 3D, so let's see how they do with that. Image to 3D allows you to upload a photo of anything. It then tries to identify what object in that photo you're focusing on, and then tries to recreate that object from that photo as a 3D model. Earlier in this video I've been using meshy.ai, as that was the tool that I was using in my previous AI Gen video for text to 3D, but for image to 3D I'm going to swap that out for Instant Mesh. When I was looking at image to 3D for my previous AI video, initially I was trying to use a photo of the incredible Atlas HD humanoid robot by Boston Dynamics. Unfortunately, Instant Mesh, which is the platform I was testing at the time, really struggled with this photo. So to keep it in the same veins, I used a different photo to create a model of the Boston Dynamic dog-like robot Spot. Even though it's only been a couple of months, this technology has really evolved, so this time I would like to try Atlas HD again. I'm going to run the same photo through Rodin Gen 1, charmed.ai and 3D AI Studio, but to kick things off I'm going to run it through Instant Mesh again to see if it's improved at all since then. Instant Mesh runs on the AI Super Playground Hugging Face, and like the earlier tools I mentioned, this is also free to use. I'll pop a link to all the tools that I use in this video in the video description. We'll upload our image of Atlas HD here. Now all of these tools prefer it if you were to upload an image with no background to confuse it. However, they all also feature an automatic isolation function which tries to figure out the boundaries of the object that you're after and then removes everything else, so I'll be using the same standard photo to test how this works. With remove background ticked, when we click generate it will then try and remove the background, but you can see here that it's not removed the areas in between the cables, so that may affect the mesh shape. It then creates 2D images of the object from each angle and finally creates a 3D model based on them, which you can preview here. Let's take a look at how this came out. Now what's cool here is that because of the way that the color material has been saved to the OBJ file, on import to Bamboo Studio, we have the ability to have it automatically paint the model for printing using the texture as a template. Now it has used 16 colours, which would require 4 full AMSs, and the actual paint job that it's applied isn't great, but it's great to have that option and that it worked at all. This will definitely improve over time, and I'm looking forward to AI models where I could specify a number of colours when generating it, and then I don't even need to paint it for printing. However, as we're looking at the mesh generation quality here, let's remove the painting entirely so we can see how the model came out. It's definitely better than the last time I tried instant mesh at this model, but there's some big flaws in the design, with bumps in the texture, missing cables, and unusually flat arms. With 3D AI Studio, we'll upload the same image, and around a minute later it's generated this. Now the applied colour material seems to more closely resemble the photo than instant mesh, and it's applied some nice detail on the back, but the general mesh shape is a little all over the place still. Let's get it refined and see if that's improved at all. Well, that definitely looks a lot cleaner than it did before refining it, and the torso shape is certainly more accurate than it was. Let's take a look in the slicer. Well, this still isn't exactly production line ready. It's got very confused about these cables, merging one into the leg and creating basically a hole through the leg, and then it's ignoring most of the others completely. Looking around the back, it's actually made the legs weirdly hollow, and up at the top here we have these two weird wing type things, one of which is just floating in mid-air. Charmed.ai took around 7 minutes and generated this for us. Weirdly, I'd say this is both the best and worst of the bunch so far. It's the least representative of the actual photo, but it also seems to be a fairly clean and neatly completed model, at least compared to instant mesh. However, it still suffers from AI bumps, its cables are merged into its arms, and the shape just isn't right in any way. Finally, we have Rodin Gen 1. Now, Image to 3D is their self-described strong suit, but they also have an extra card up their sleeve here. You can just upload a single image and it will generate a 3D model from that, but even with that, this seems to do a far cleaner job than the other tools, albeit with its own interpretations of the other side of the model which it obviously can't see from the photo. However, in addition to uploading that one image, you can also upload another image of the object from a different angle, allowing up to 5 images in total for one generation. So I'll upload 3 other images here of Atlas from different angles. When we click Generate, we get 2 new options, Multi-View and Fusion. Fusion is for if you were to upload or generate images from text prompts of completely different things, and it will then try and merge them into a single object. For example, taking the aesthetic styling of one and applying it to the geometric shape of the other. Multi-View is when uploading multiple images of the same object from different angles, and that's what we want here. It should be noted that these photos that I've uploaded aren't all from a single collection. They're actually of different versions of Atlas HD and taken at different times by different people. So you don't necessarily have to have access to a specific model and take photos of different angles yourself. These are just photos that I found online at different places. And here you can see our draft model, and it looks remarkably similar to the original image. So let's generate this final mesh, get it downloaded, and take a look at them all in a slicer. Whilst we're looking at Image to 3D, one other tool that I thought I should look at here is the Image to 3D Model tool by Bamboo Lab, available at makerworld.com. However, when I uploaded a photo of Atlas, it came up with a warning saying that the image contains sensitive content and refused to use it. So I tried 2 different photos of Atlas and got the same warning on each. So I figured it was probably getting confused about the general shape of Atlas, thinking it was some sort of naked person. So I decided to try something very different. I uploaded a photo of one of the most infamous 3D prints in the world, a 3D Benchy, and this also apparently contains sensitive content. So unfortunately my Bamboo Lab MakerWorld experiments for this video ended before they began. Let's get back to the models that did work. It's a pretty stark difference between these 4 models. Charmed AI, Instant Mesh, and even 3D AI Studio all struggled to properly identify the cables and general shape of the robot. There was obviously just too much fine detail going on, and that was just enough to confuse them, especially with the background. However, it goes beyond just image recognition issues. All 3 of those featured the AI bumpy surface, though granted significantly less so on the 3D AI Studio one. The 3D AI Studio Atlas model is on the whole notably higher quality and more accurate to the photo than the other two, but all three of these also ended up having curved or uneven bases to their feet, so will each need their bottom of their feet cut off to easily print upright. By contrast, the one from Rodin Gen 1 is far more accurate to the photo, displays significantly more features and details whilst retaining a smooth, bump-free surface, and also has flat feet that don't require cutting to stand upright. Okay, let's get these all printed. What's really impressive here is even when you're just using an image and not a text prompt, Rodin Gen 1 seems to understand what it's actually generating. So not just the geometry that it can determine from the image, but what the actual object is. So when you're creating an image to 3D from a single image, it's obviously analysing the image, figuring out what the object in it is, and then making an educated guess as to the hidden geometry. To demonstrate this a little better, let's upload this photo of a frog, and we'll just upload the one photo. Now this photo only shows one eye and 3 feet, and due to the angle that the photo is taken and the fairly shallow depth of field, there is a lot of guesswork involved in figuring out what the rest of the object actually looks like. However, once generated, it was clear that it understood that it was a frog that it was making and what shapes a frog typically features. As a result, it's included the hidden leg, foot and eye, and hasn't got some sort of random leg or wheel sticking out of its back or something. Now I mentioned earlier that in Rodin Gen 1 you can use up to 5 uploaded photos or text prompt generated images per generation. Not just so you can provide different angles of the same object, but also so you can merge multiple objects into one, and I thought I'd give you a demonstration of that here. I'll take an image of a humanoid robot and add that, and then I'll add another prompt, this time selecting an image of a toaster with some toast sticking out the top. If I now select Generate and then Fusion, it will try and fuse these two objects or styles together. It's created a humanoid robot for us that looks fairly similar to the original image of the robot, but I'm not seeing the toaster here. As I rotate the model though, you'll see that its body has been inspired by the shape of the toaster, and its head is shaped like the toast sticking out the top. Let's get this model finalised and then let's generate a texture using the toaster image. And there we go, we now have a 3D model of a humanoid toaster robot with a slice of toast for a head. With all the Atlas models printed, the ones by 3D AI Studio, Charmed and Instant Mesh are all fairly obviously robots, albeit very weird, and they certainly don't look like Atlas. The one generated by Rodin Gen 1 however looks excellent, and I couldn't help but give it a paint job. The accuracy and detail in this model has honestly blown me away, from the shape and connections of these pretty small cables to the posture and surface finish. Speaking of posture, they're all amazingly able to stand upright freestanding, with the exception of the one from Instant Mesh, who I needed to use double-sided sticky tape for him to stand up, and eventually his super thin ankle broke off. Though this was only possible with the Instant Mesh, Charmed and 3D AI Studio ones because I cut the bottom of their feet off in the slicer, with the one from Rodin Gen 1 being the only one that could do this natively. At the end of my last video on AI mesh generation, I summarised that, sure, these tools are far from perfect and the models that they generate are heavily flawed, but this technology moves so fast it's only going to be a matter of time. I wasn't expecting that matter of time to only be 2 months, but honestly, if I wanted to print a model of an Atlas HD robot, this would be more than good enough for me. I love this little guy. I think he's probably going to have to live on top of my computer next to my Boston Dynamics Spot robot, which I printed last time. And I'm also thinking that I might need to print a larger version of him, so keep an eye out for a short on that soon. I'm looking forward to seeing how this all evolves at the next step, and I'll be sure to bring you more like this very soon. Some of you may have been disappointed to watch one of my mesh generation videos that didn't feature my horse with a gas mask. I usually crack him out for 3D scanning tests, and he's going to be on your screens quite a bit very soon. In preparation for that, I feel it's just about time that he has a name, so pop your suggestions in the comments. It's clear that these tools are getting better and fast, but what do you think? Is it something you're going to be using, and if so, what will you be using it for? I really hope you found this video interesting, and if you did, please do hit that like button. While you're down there, hit the subscribe button so you don't miss my 3D printing, maker tech and AI videos in the future. If you hit the join button below my video, you can become a channel member, getting early access to my videos, exclusive access to the 3D Rev Discord community, access to longer cuts of my videos in the future, and a members discount at 3drevolutionstore.com. More importantly, thank you very much everyone, and until next time, happy printing. Thanks everyone for watching, and a special thank you to my channel members for all your support. If you enjoyed this video, you might like to see my earlier video on AI 3D generation, where I looked at how to create a 3D model from a video. Or pop on one of my other videos, learn something new, or have some fun. Thanks very much everyone, and until next time, happy printing.